In this video, we're going to be taking a look at activity 417, known as the Automata simulation, utilizing the cams that we've created in earlier lessons. So here in the video, this is a completed automata based on simulation, and this video is going to go through how to put the cams in, adjust the followers so then that way they will write on the cams, and then also how to adjust the ruler so you can take measurements utilizing your specific cams in order to help collect those measurements and create motion graphs for your particular automata motions. So here in this is a completed one. I'm going to go ahead and hit cancel on the animation that we're running, and we're going to follow the steps in order to do so. So I'm going to move over. I did from the IED curriculum 417, this is the automata no cams box that was created. So I'm going to go ahead and I've got this open in a new tab. This is where we're going to start with. I'm going to close down the completed one, making sure that I save. And with this is a part that is already been created. So the followers, the follower guides, the box, the axle, the crank handle, and some of the other components are already placed in there for you. All we're looking for is to add those cams in. Before we do so, I'm going to do this real quick, is I'm going to activate the left side component for our box, and I'm going to change the physical material. So I can click on the modify panel, go to physical material, and choose acrylic clear as we go through there. And I'm going to drag and I'm going to put onto that box side, and I'm going to hit close. I'm going to do the same thing going to the box right, activate the component, running the physical material. I've got it pinned to my toolbar here, acrylic clear, and then I apply that to the material. And then I'm going to go back up to the top level of the assembly and activate the top level. Now you're going to be able to see through the box. It's going to make it a lot easier. Rather than hiding those box sides, I think it's a lot easier to see the clear acrylic in there. Okay, what I'm going to end up doing is I'm going to bring in some of the cams and start looking at constraining them. So I'm going to go ahead and turn this over to the side. I'm going to open up my data panel. I'm going to go back to one of the previous folders that I created, which dealt with the cams that I parametrically modeled in activity 412. I'm going to drag the Pear cam in. And one thing that we're going to deal with is I'm going to go ahead and move this into position approximately where we're wanting it, and let's go ahead and get this placed so then that way that it is in the proper position that we want it to be in when we go to install it. So the little bump that is that's going to be experienced by the follower, we want that to be in the downward position, kind of like how I've shown here, and I'm going to go ahead and say OK. Now when I go through and install this cam into the box, I'm going to use the joint command. I'm going to use the rigid motion. You can also check from it from the tab. And what I'm going to do is I'm going to zoom in, and I want to choose the circle, and I'm going to go ahead and redo that just in case. So when I do select on my cam, so the part that's going to be created, I want to go ahead and select around the outside circle where the joint origin chip is kind of on the outside edge. And then I'm going to go over here, I'm going to do the same thing, choosing the outside. It's kind of hard to see with the black handle on the color for the crank handle, but I'm going to go ahead and click there. And I want to make sure, this is really important when I set this on here, is I want to make sure that the front edge of the cam is flush with the edge of the axle that's being put there. Now here's what I'm going to do before I say OK. I'm going to go ahead and turn this to the front, and I'm going to offset this in the Z direction. Now it just so happens the Z direction offset to make these very nice is 1.25, and that'll put the cam directly below the follower and right on the roller. And I'm going to go ahead and say OK. Now here's the process that we're going to do in order to have this. So your Revolut Joint, so if you expand the joints folder, let me close the data panel. And here you got the Revolut Joint, which is actually when you animate the joint, it's going to be the axle turning, so you can see that happening there. I'm going to right click and say cancel to stop that animation. And if you click and drag the handle, you're going to see what kind of motion you get when you from the cam as you turn it. Now the thing is when I installed the cam, and this is going to be very important for future cams, is we want to make sure that this Revolut 9 goes back to the home position, which is set on our gauge to be right at 0 degrees. And we want that cam, as you can tell from the clear acrylic box, that we want that to be in the lowest position possible. It means the roller will not go through and go up. It'll be in the lowest position when we're starting. So let me go ahead and turn this back around. One thing that I'm going to do as I take a look is I need to figure out how much of an offset. So right now these followers have a slider joint to slide up and down in the follower guide. So what I'm going to do though is let me go ahead and revert and put this back into position. Those slider joints are noted by slider 40, 41, 42, and 43. So you'll see if you click on one, you'll see where it highlights. The first one, which is above our Pear cam, is going to be slider 40. I'm going to right click and I'm going to say edit joint. Now the thing you're going to notice is that our cam disappears because we're just editing the joint, and same thing here. So the slider is dealing with our roller, and here it has an offset of 1.5. So here it's most likely they've clicked on the top and then they've gone through and they've offset that by 1.5. So we're going to keep this in mind as we go forward. I'm going to go ahead and hit cancel. Now what I need to know is how much distance do I have between the roller and between the top of the cam. So I'm going to go ahead and turn this to the side a little bit, and I'm going to run the measure tool. I'm going to choose the bottom of the roller, so right there in the middle, and that way it gets the rounded edge, and I'm going to choose the rounded edge of the cam. Now you're going to get two values. Since these are rounded values, they're also going to pick up the center points. So here you have the center point of your cam, you have the center point of the arc for the roller. Now that is going to be, you'll notice they'll have a distance of 1.725, but actually the minimum distance, when you look at the arrows, we're wanting to know what's the distance from the bottom edge of the cam, the roller, to the top edge of the cam. 0.475. So I'm going to keep that value, 0.475. I'm going to go back to my slider. I'm going to edit the joint, and I'm going to go ahead and I'm going to do plus 0.475. And you're going to notice that roller is going to drop down. This is going to run the equation for us, and I'm going to say OK. And now when you take a look, now the roller is going to be right on top of the cam, which is exactly what we want here. All right, so that's kind of the process for adding the Pear cam. Now, once we've got the roller set in place, we need to know how much of a displacement that this cam is going to give. This is a 2-inch nominal diameter cam. So what I'm going to do is I'm going to scroll down here into my folder, and here's my Pear cam, and I'm going to go ahead and I'm going to take a look at, now you're going to notice they have an edit in place option. So if I hit edit in place, it's going to ask me to turn on that associativity. And really what I want to do is I really don't want to edit this cam so much as I just want to get a little bit of information about it. So if I expand the Pear cam here, you'll actually see here's your sketch. So I'm going to go right click and say edit sketch. Now one thing that I need to see is that this cam is going to ride, the follower is going to ride along the cam, and it's going to really stay sitting down until it hits this bump at the top. So really I need to see how much of a displacement that I have. So you'll see I've got a point here and a point here. And if you don't have a point, you can always go to create, choose point, and put one right there at the center when you go to edit the cam. So that's really something you can do. But I'm going to use the measure tool. I'm going to click on this dot and see that the amount of difference or displacement that it should when that follower rotates around and bumps up is 1/4 inch. So I'm going to go ahead and hit close. I'm just going to go through and get that information. I'm going to finish the sketch. I'm really not editing the cam. I'm just getting that information from the sketch geometry. So I'm going to go ahead and collapse these there. And then here's what I'm going to do. I'm going to go back up to the top level, and I want to go ahead and hit the green check mark. You'll notice I'm still editing that Pear cam. So when I hit the green check mark, it stops that, and then I can activate the top level for the assembly. Okay, so for here, the slider joint, I'm going to right click and I'm going to choose Edit Slider Joints. You're going to notice the icon there. You can also click the little icon next to it. And the maximum, referring to the maximum limit we want to go ahead and put in what that cam displacement is. Now it looks like it's going to go down into the cam, but we want to go ahead and set the rest position to be at 0. So 0 is going to be sitting right where it's at. And I'm going to say OK. Now once I get that first cam in, I can go to Assemble, and I can say Enable All Contact. And then what we'll notice to test this out, so if I drag that handle, it rotates around, and then the follower goes up and stays on the profile as well. So the one thing you'll notice if you leave it at 180, it does kind of will move your crank handle, but it is following the cam, and it is responding when it goes through and gets that motion as appropriate. So at this point, we're going to go ahead and stop the video, and I'm going to be taking a look at putting in 3 other cams throughout the video. You're going to see a very similar process, and from here, we're going to look at, well, how do we adjust a few things and make sure that we how do we gain some information from this assembly to be able to create a motion graph in this